In automotive engineering, a multivalve or multivalve engine is one where each cylinder has more than two valves. A multivalve engine has better breathing and may be able to operate at higher revolutions per minute than a two-valve engine, delivering more power. Multivalve rationale equals multivalve design equals a multivalve design typically has 3, 4, or 5 valves per cylinder to achieve improved performance. Any four-stroke internal combustion engine needs at least 2 valves per cylinder, one for intake of air and fuel, and another for exhaust of combustion gases. Adding more valves increases valve area and improves the flow of intake and exhaust gases, thereby enhancing combustion, volumetric efficiency, and power output. Multi-valve geometry allows the spark plug to be ideally located within the combustion chamber for optimal flame propagation. Multi-valve engines tend to have smaller valves that have lower reciprocating mass, which can reduce wear on each cam lobe, and allow more power from higher RPM without the danger of valve bounce. Some engines are designed to open each intake valve at a slightly different time, which increases turbulence, improving the mixing of air and fuel at low engine speeds. More valves also provide additional cooling to the cylinder head. The disadvantages of multi-valve engines are an increase in manufacturing cost and a potential increase in oil consumption due to the greater number of valve stem seals. Some SOHC multi-valve engines use a single fork-shaped rocker arm to drive 2 valves so that fewer cam lobes will be needed in order to reduce manufacturing costs. 3 valves cylinder head. This is a single large exhaust valve and 2 smaller intake valves. A 3-valve layout allows better breathing than a 2-valve head, but the large exhaust valve results in an RPM limit no higher than a 2-valve head. The manufacturing cost for this design can be lower than for a 4-valve design. The 3-valve design was common in the late 1980s and early 1990s. And from 2004 the main valve arrangement used in Ford F-Series trucks and Ford SUVs. 4-valve cylinder head. This is the most common type of multi-valve head, with 2 exhaust valves and 2 similar inlet valves. This design allows similar breathing as compared to a 3-valve head, and as the small exhaust valves allow high RPM, this design is very suitable for high power outputs. 5-valve cylinder head. Less common is the 5-valve head, with 2 exhaust valves and 3 inlet valves. All 5 valves are similar in size. This design allows excellent breathing, and, as every valve is small, high RPM and very high power outputs are theoretically available. Although, compared to a 4-valve engine, a 5-valve design should have a higher maximum RPM, and the 3 inlet ports should give efficient cylinder filling and high gas turbulence, it has been questioned whether a 5-valve configuration gives a cost-effective benefit over 4-valve designs. After making 5-valve Genesis engines for several years, Yamaha has reverted to the cheaper 4-valve design. Beyond 5 valves, for a cylindrical bore and equal area-sized valves, increasing the number of valves beyond 5 decreases the total valve area. The following table shows the effective areas of differing valve quantities as proportion of cylinder bore. These percentages are based on simple geometry and do not take into account orifices for spark plugs or injectors, but these voids will usually be sited in the dead space unavailable for valves. Also, in practice, intake valves are often larger than exhaust in heads with an even number of valves per cylinder. 2 equals 50%, 3 equals 64%, 4 equals 68%, 5 equals 68%, 6 equals 66%. 7 equals 64%, 8 equals 61%. Alternative technologies equals. Turbocharging and supercharging are technologies that also improve engine breathing, and can be used instead of, or in conjunction with, multi-valve engines. The same applies to variable valve timing and variable intake manifolds. Rotary valves also offer improved engine breathing and high rev performance, but these were never very successful. Cylinder head porting, as part of engine tuning, is also used to improve engine performance. Cars and trucks. Before 1914 the first motor car in the world to have an engine with 2 overhead camshafts and 4 valves per cylinder was the 1912 Peugeot L76 Grand Prix race car designed by Ernest Henry. Its 7.6-litre monoblock straight-four with modern hemispherical combustion chambers produced 148 bhp. In April 1913, on the Brooklands racetrack in England, a specially built L76 called La Torpille beat the world speed record of 170 km per hour. Robert Peugeot also commissioned the young Étoile Bugatti to develop a GP racing car for the 1912 Grand Prix. This chain-driven Bugatti Type 18 had a 5-litre straight-four with SOHC and 3 valves per cylinder. It produced APPR 100 bhp at 2800 rpms and could reach 99 miles per hour. The 3-valve head would later be used for some of Bugatti's most famous cars, including the 1922 Type 29 Grand Prix racer and a legendary Type 35 of 1924. Both Type 29 and Type 35 had a 100 bhp 2-litre SOHC 24-valve NA-8 that produced 0.82 bhp per cubic inch. Equals between 1914 and 1945 equals, ALFA. 40/60 GP was a fully working early racing car prototype made by the company now called Alfa Romeo. Only one example was built in 1914, which was later modified in 1921. This design of Giuseppe Merosi was the first Alfa Romeo DOHC engine. It had 4 valves per cylinder, 90-degree valve angle and twin-spark ignition. The GP engine had a displacement of 4.5-litre and produced 88 bhp at 2950 rpms, and after modifications in 1921 102 bhp at 3000 rpms. The top speed of this car was 88 to 93 miles per hour. It wasn't until the 1920s when these DOHC engines came to Alfa road cars like the Alfa Romeo 6C. In 1916 U.S. automotive magazine Automobile Topics described a 4-cylinder, 4-valve per cylinder car engine made by Linthwaite Hussey Motor Company of Los Angeles, California, USA. Firm offers 2 models of high-speed motor with twin intakes and exhausts. Early multi-valve engines in T-head configuration were the 1917 Sto straight-four and 1919 Pierce Arrow straight-six engines. The standard flat-head engines of that day were not very efficient and designers tried to improve engine performance by using multiple valves. The Sto's Motor Company used a modified T-head with 16 valves, twin-spark ignition and aluminium pistons to produce 80 bhp at 2400 rpms from a 360.8 SID straight-four. Over 2,300 of these powerful early multi-valve engines were built. Sto's not only used them in their famous Barcat sports car but in their standard touring cars as well. In 1919 Pierce Arrow introduced its 524.8 SID straight-six with 24 valves. The engine produced 48.6 bhp and ran very quietly, which was an asset to the bootleggers of that era. Multi-valve engines continued to be popular in racing and sports engines. Robert M. Roof, the chief engineer for Laurel Motors, designed his multi-valve roof racing overheads early in the 20th century. Type A 16-valve heads were successful in the teens, Type B was offered in 1918 and Type C 16-valve in 1923. Frank Lockhart drove a Type C overhead cam car to victory in Indiana in 1926. Bugatti also had developed a 1.5-litre OHV straight-four with 4 valves per cylinder as far back as 1914 but did not use this engine until after World War I. It produced APPR 30 bhp at 2700 rpms. In the 1920 Voiture Grand Prix at Le Mans, driver Ernest Friedrich finished first in a Bugatti Type 13 with a 16-valve engine, averaging 91.96 km per hour. Even more successful was Bugatti's clean sweep of the first 4 places at Brescia in 1921. In honor of this memorable victory, all 16-valve engine Bugattis were dubbed Brescia. From 1920 through 1926 about 2,000 were built. Peugeot had a triple overhead cam 5-valve Grand Prix car in 1921. Bentley used multi-valve engines from the beginning. The Bentley 3-litre, introduced in 1921, used a monoblock straight-four with aluminium pistons, pent roof combustion chambers, twin-spark ignition, SOHC, and 4 valves per cylinder. It produced APPR 70 bhp. The 1927 Bentley 4.5-litre was of similar engine design. The NA Racing model offered 130 bhp in the 1929 supercharged 4.5-litre reached 240 bhp. The 1926 Bentley 6.5-litre added 2 cylinders to the monoblock straight 4. This multi-valve straight 6 offered 180 to 200 bhp. The 1930 Bentley 8-litre multi-valve straight 6 produced APPR 220 bhp. In 1931 the Stuss Motor Company introduced a 322-SID dual camshaft 32-valve straight 8 with 156 bhp at 3900 rpms, called DV32. The engine offered 0.48 bhp per cubic inch. About 100 of these multi-valve engines were built. Stuss also used them in their top-of-the-line sports car, the DV32 Superbarcat that could reach 100 miles per hour. The 1935 Duesenberg S.J. Moorman Meteor's engine was a 419.6 SID straight 8 with DOHC, 4 valves per cylinder and a supercharger. It achieved 400 bhp at 5,000 rpms and 0.95 bhp per cubic inch. The 1937 Mercedes-Benz W125 racing car used a supercharged 5.7-litre straight 8 with DOHC and 4 valves per cylinder. The engine produced 592 to 646 bhp at 5,800 rpms and achieved 1.71-1.87 bhp per cubic inch. The W125 top speed was APPR 200 miles per hour. After 1945 equals. The 1967 Cosworth Dfv F1 Engine, a NA 3.0-litre V8 producing APPR 400 bhp at 9,000 rpms, featured 4 valves per cylinder. For many years it was the dominant engine in Formula One, and it was also used in other categories, including kart, Formula 3000 and sports car racing. Debuting at the 1968 Japanese Grand Prix in the original 300 picoseconds 3.0-litre version, the Toyota 7 engine participated in endurance races as a 5.0-litre non-turbo V8 with DOHC and 32 valves. It produced 600 picoseconds at 8,000 rpms and 55.0 km at 6,400 rpms. The first mass-produced car using 4 valves per cylinder was the British Jensen Healey in 1972, which used a Lotus 907 belt-driven DOHC 16-valve 2-litre straight 4 producing 140 bhp. The 1973 Triumph Dolomite Sprint used an in-house developed SOHC 16-valve 1998 cc straight 4 that produced APPR 127 bhp. The 1975 Chevrolet Cosworth Vega featured a DOHC multi-valve head designed by Cosworth Engineering in the UK. This 122 cubic inch straight 4 produced 110 bhp at 5,600 rpms and 107 lb-ft at 4,800 rpms. The 1976 Fiat 131 Abarth, 1976 Lotus Esprit with Lotus 907 engine, and 1978 BMW M1 with BMW M88 engine all used 4 valves per cylinder. The BMW M88/3 engine was used in the 1983 BMW M635 XC and in the 1985 BMW M5. The 1978 Porsche 935/78 Razor used a twin-turbo 3.2-litre flat 6. The water-cooled engine featured 4 valves per cylinder and output a massive 196.2 kilowatts per litre. Porsche had to abandon its traditional air cooling because the multi-valve DOHC hampered air cooling of the spark plugs. Only 2 cars were built. Ferrari developed their Quattrovalve engines in the 80s. 4 valves per cylinder were added for the 1982 308 and Mondial Quattrovalve, bringing power back up to the Prix FI high of 245 horsepower. A very unusual Dino Quattrovalve was used in the 1986 Lancia Thema 8.32. It was based on the 308 QV's engine, but used a split-plane crankshaft rather than the Ferrari-type flat plane. The engine was constructed by Ducati rather than Ferrari, and was produced from 1986 through 1991. The Quattrovalve was also used by Lancia for their attempt at the World Sports Car Championship with the LC2. The engine was twin-turbocharged and de-stroked to 2.65 litres, but produced 720 horsepower in qualifying trim. The engine was later increased to 3.0 litres and increased power output to 828 horsepower. The 1984 Ferrari Testarossa had a 4.9-litre flat 12 with 4 valves per cylinder. Almost 7,200 Testarossa were produced between 1984 and 1991. In 1985 Lamborghini released a Countach Quattrovalve, producing 455 picoseconds from a 5.2-litre Lamborghini V12 engine. The Mercedes-Benz 190e 2.3-16 with 16-valve engine debuted at the Frankfurt Auto Show in September 1983 after it set a world record at Nardo, Italy, recording a combined average speed of 154.06 miles per hour over the 50,000 km endurance test. The engine was based on the 2.3-litre 8-valve 136 horsepower unit already fitted to the 190 and E-Class series. Cosworth developed the DOHC light alloy cast cylinder head with 4 large valves per cylinder. In rear-going trim, the 190e 2.3-16 produced 49 horsepower and 41 Euro-cent lb-f of torque, more than the basic single overhead cam 2.3 straight-4 engine on which it was based, offering 185 horsepower at 6,200 rpms and 174 lb-ft at 4,500 rpms. In 1988 an enlarged 2.5-litre engine replaced the 2.3-litre. It offered double-valve timing chains to fix the easily snapping single chains on early 2.3 engines, and increased peak output by 17 bhp with a slight increase in torque. For homologation Evolution I and Evolution II models were produced that had a redesigned engine to allow for a higher rev limit and improved top-end power capabilities. The Evo 2 engine offered 235 picoseconds from 2463 cc's. Saab introduced a 16-valve head to their 2.0-litre straight-4 in 1984 and offered the engine with and without turbocharger in the Saab 900 and Saab 9000. The 1.6-litre 4AGE Toyota engine was one of the earliest straight-4 engines to have both a DOHC 16-valve configuration and electronic fuel injection. The cylinder head was developed by Yamaha Motor Corporation and was built at Toyota's Shimeyama plant. While originally conceived of as a 2-valve design, in 1984 Toyota and Yamaha changed the 4AGE to a 4-valve after a year of evaluation. It produced 115 to 140 bhp/86 to 104 kilowatts at 6,600 rpms and 148 Nm/109 lb-ft at 5,800 rpms. To compensate for the reduced airspeed of a multi-valve engine at lower PM, the first-generation engines included the TVS feature. In 1986 Volkswagen introduced a multi-valved Golf Gti 16V. The 16-valve 1.8-litre straight-4 produced 139 picoseconds or 56.7 kilowatts per litre, almost 25% up from the 45.6 kilowatts per litre for the previous 8-valve Golf Gti engine. The GM Quad 4 multi-valve engine family debuted early 1987. The Quad 4 was the first mainstream multi-valve engine to be produced by GM after the Chevrolet Cosworth Vega. The NA Quad 4 achieved 1.08 bhp per cubic inch. Such engines soon became common as Japanese manufacturers adopted the multi-valve concept. 3 valves. The 1984 Honda CRX and 1985 Honda Civic introduced Honda's 1.5-litre SOHC 12-valve straight-4 engines. Nissan's 1988 to Euro 1992 SOHC KA24E engine had 3 valves per cylinder as well. Nissan upgraded to the DOHC after 1992 for some of the sports cars, including the 240SX. Mercedes and Ford produced 3-valve V6 and V8 engines, Ford claiming an 80% improvement in higher PM breathing without the added cost of a DOHC valve train. The Ford design uses one spark plug per cylinder located in the center, but the Mercedes design uses two spark plugs per cylinder located on opposite sides, leaving the center free to add a direct-to-cylinder fuel injector at a later date. The 1989 Citroën NXM was the first three-valve diesel-engined car. Four valves. Examples of SOHC four-valve engines include the Honda F-Series engines, D-Series engines, all J-Series engines, the R-Series engines, the Mazda B8 ME, the Chrysler 3.5L V6 engine. The V12 engines of many World War II fighter aircraft also used a SOHC configuration with four valves for each cylinder. The 1993 Mercedes-Benz C-Class was the first four-valve diesel-engined car. Five valves. Peugeot had a triple overhead cam five-valve Grand Prix car in 1921. In April 1988 an Audi 200 Turbo Quattro powered by an experimental 2.2-litre turbocharged 25-valve straight 5 rated at 478 kilowatts per 650 picoseconds at 6,200 RPMs set two world speed records at Nardo, Italy, 326.403 km per hour for 1,000 km and 324.509 km per hour for 500 miles. Mitsubishi were the first to market a car engine with 5 valves per cylinder, with the 548cc's 3G81 engine in their Minica Dangon ZZ Carry car in 1989. Yamaha designed the 5-valve cylinder head for the Toyota 4AGE 20V 1991 silver top and 1995 black top engine used in some Toyota Corolla. Yamaha also developed 5-valve Formula One engines, the 1989 OX88 V8, 1991 OX99 V12, 1993 OX10 V10 and 1996 OX11 V10, but none of these were very successful. For their YZ250F and YZ450F motocross bikes, Yamaha developed 5-valve engines. Bugatti, Ferrari, Volkswagen, Audi, Skoda and Toyota have all produced 5-valve engined vehicles. 6 valves. In 1985 Maserati made an experimental 2.0-litre turbo V6 engine with 6 valves per cylinder. It achieved 261 bhp at 7,200 rpms. Pushrod. Although most multi-valve engines have overhead camshafts either SOHC or DOHC, a multi-valve engine may be a pushrod overhead valve engine design. Chevrolet has revealed a 3-valve version of its Generation 4 V8 which uses pushrods to actuate forked rockers, and Cummins makes a 4-valve OHV straight-six diesel, the Cummins B-Series. Ford also uses pushrods in its 6.7L Power Stroke engine using 4 pushrods, 4 rockers and 4 valves per cylinder. Turbocharged. The 1981 Maserati Biturbo was the first production car to use a multi-valve turbocharged engine. Motorcycles. Examples of motorcycles with multi-valve engines include 1914 Peugeot Grand Prix Racer, 500cc's DOHC 8-valve parallel twin. 1915 Indian Board Track Racer, 61 SID OHV 8-valve V-twin. 1921 Triumph Ricardo 499cc's OHV 4-valve single-cylinder machine, copied by Rudge Whitworth with their 1924 Rudge 4 350cc's OHV 4-valve single-cylinder machine, and 1929 Rudge Austro 500cc's OHV 4-valve single-cylinder machine. 1923 British Anzani 1098cc's OHV 8-valve V-twin, used in Morgan three-wheelers and McEvoy motorcycles. 1972 Honda XL 250 Pent Roof SOHC 4-valve single-cylinder machine. 1973 Yamaha TX 500 Pent Roof 500cc's DOHC 8-valve parallel twin. 1977 Honda CB 400 SOHC 6-valve parallel twin. 1978 Honda CX 500, a 498cc's SOHC, pushrod actuated OHV, 4-valve per cylinder V-twin. 1982 CX 500 Turbo was the first factory multi-valve turbocharged motorcycle. 1978 Honda CBX 1000, a 1047cc's DOHC 24-valve straight-six. 1979–1992, Honda NR Series, racing and production motorcycles with 8-valve per-cylinder oval piston V4 engines. 1985 Yamaha FZ750 motorcycle with DOHC 20-valve straight-4 Yamaha Genesis engine. 1991–2010 Yamaha TDM 850cc and N900cc motorcycles with 5 valves per cylinder. 1998 to Euro 2006 Yamaha YZF-R1 superbike with redesigned Genesis engine. 2006 model delivered 180 bhp at 12,500 rpms. The Yamaha XT660 single once had 5 valves per cylinder, but a subsequent redesign reduced the valve count to 4. The Aprilia Pegaso 650 single also started out with 5 valves, but current models only have 4. The jointly developed BMW F650 single always had 4 valves. Aircraft. Tour Bugatti designed several multi-valve aircraft engines. The 1916 Bugatti U16 1484.3 SID SOHC 16-cylinder, consisting of 2 parallel 8-cylinder banks, offered 410 bhp at 2000 rpms. Each cylinder had 2 vertical inlet valves and a single vertical exhaust valve, all driven by rocking levers from the camshaft. Other advanced World War I aircraft engines, such as the 1916 Maybach MB-IVA that produced 300 bhp at altitude and the 1916 Benz BZIV with aluminium pistons and the 1918 Napier Lion, used 2 intake valves and 2 exhaust valves. The V12 engines of many World War II fighter aircraft used a SOHC configuration with 4 valves for each cylinder. An example of a modern multi-valve piston engine for small aircraft is the Austro engine A300. This liquid-cooled turbocharged 2.0-litre DOHC 16-valve straight-4 diesel engine uses common rail direct fuel injection and delivers 168 bhp at 3,880 rpms. The propeller is driven by an integrated gearbox with torsional vibration damper. Total power unit weight is 185 kilograms. Boats. In 1905 car builder Delahaye had experimented with a DOHC marine racing engine with 6 valves per cylinder. This Delahaye Titan engine was a massive 5190 SID 4-cylinder that produced 350 bhp. It allowed the motorboat Bled Bonnet piloted by Mild Bonnet to set a new world speed record on water, reaching 33.80 miles per hour on the lake at Juvisy, near Paris, France. An example of modern multi-valve engines for small boats is the Volvo Penta IPS series. These joystick-operated seawater-cooled inboard diesel engines use combined charging with aftercooler, common rail fuel injection and DOHCs with hydraulic 4-valve technology. Prop shaft power ranges from 248 to 850 bhp. Multiple units can be combined. References. External links, kinematic models for design digital library, movies and photos of hundreds of working mechanical systems models at Cornell University. Also includes an ebook library of classic texts on mechanical design and engineering.